Assalamu alaikum wa rahmatullahi wa barakatuh. Today we have a mathematics session. It's about the exponential and natural logarithm functions. Here we are discussing section 2.4 in the course Math 103b and Math 103. Okay, what is the main objective of this presentation? We want to solve equations that contain the exponential e and natural logarithm. So this is the main objective that we are trying to achieve in this presentation. In the last section, section 2.3, we noted that if a number m can be expressed as p to the power n, then n is called the logarithm of b of m to the base of b. In particular, if we have the base e, not b, if we have the base e, not b. Sorry for this. Let's go and so if we have instead of b here, I don't have b. What if I have e? So I just replace b by e. Then if we have m equals e to the power n, then n equals log m at the base of e. So what is the main difference here? Instead of having b, I have now e. So what is that big deal? Why do you want to replace b by e? Now, actually, the logarithm which has base e, it's called natural logarithm. We know that the logarithm that has logarithm base 10, we call it common logarithm. So when we have a logarithm which has a base e, we call this logarithm natural logarithm. Now this occurs sufficiently frequently to warrant their own notation. Rather than writing log m at the base of e, then we can simplify both len m. So instead of writing log m at the base of e, no, we just replace it as len m. So we called the logarithm to the base e, we expressed as len e, not logarithm m at the base of e. So I'll just go with you to section 2.3. In section 2.3, as you see, if this is the common logarithm, when we have logarithm 10 at the base of x, this is called logarithm x, and we usually do not write the base because it's by default it is 10, and we call this logarithm common logarithm. Now when we have the base e, then we call this natural logarithm, and we write it, or we express it as len x. So whenever you see log x, this is common logarithm to the base of 10, even if we do not write it. And whenever you have log e at the base of x, so the base is 10 e, so we write it len x, and we call this natural logarithm. So this is common logarithm at the base of 10, and this is natural logarithm at the base of e, and we call it, or we write it len x. So what is this e? Why do we write e? And what is the value of e? What is this e? Now e, it is a number like pi. We know that pi equals 3.14, etc. And e is also number. Now this number e, it is non-repeating, it is never-ending decimal, and it is irrational number. Irrational number, it cannot be written in the form of a over b. One of the mistakes for it cannot be written, such as exactly like b. It's an irrational number. It cannot be written in the form of a over b. Okay, so e, the approximate value for e is 2.718281828, etc. So when we have e, which equals to 2.71828, etc., e, when it is the base of natural logarithm len, just like 10, it is the base of logarithm. So again, natural logarithm, it is written as log x at the base of e, and we express it as len e. So whenever you have len, this is logarithm, and the base equals to e. As we said, E, it is non-repeating, never-ending decimal, and irrational number, and approximately equals to 2.71828. Now, how can I calculate E? By using the calculator. It's very simple. If you want to find out how much is E, then by using your calculator, just first of all press on Shift, then press on this button. As you see, there is len, and above this bottom there is e to the power x, just to say that, or to explain that the base of this logarithm is the number e. So shift len, then equals 1. So this is give you, or it's giving you e to the power 1, and then press equal, then you will have the value of the exponential 2.7182828, etc. Now the natural logarithm, again, just to remind you, the natural logarithm, it can be written as len x and has a base of e. So it is logarithm, but it has a base of e. Now I want you to calculate e to the power 5, e to the power 6.2, e to the power, or 3 times e to the power minus 6, and e to the power 1/3. Again, let's say that this is shift len 5. This is shift, then len, I'm talking about the first one, and then 5. And then equals, you will have the value of this number. Okay, let's proceed. Now, because in the natural logarithm, or len, the base is e, okay, all properties of logarithm apply to natural logarithm. So natural logarithm, it is logarithm. So the rules of logarithm will be applied here on natural logarithm. Again, anytime you see len, you can rewrite it as log e, or log at the base of e, log x, len x. For example, len x, this is log x at the base of e. For example, len 12, it is log 12 at the base of e. Again, we said this is logarithm. How can I calculate len 170? It's simply just press on len, then 170. Len and 170. Let me just tell you, this is len, and then 170. Len 170 by using the calculator. This will be len 170. It is 5.135. So it equals to 5.135. And you can do for all these problems. Take care about len minus 4 and tell me, and then after that think why do you have this answer from your calculator, len minus 4. Okay. Now we want to, if you want to know how to give the equivalent occasion, if you are given, for example, the exponential occasion, how to write the equivalent corresponding equivalent logarithmic occasion, or vice versa. If you are given logarithmic occasion, how to write the exponential occasion. So I have here 1, 2, 3, 4, 5, 6 problems. The first 3 are written in the form of exponential, and you are requested to write the equivalent logarithmic occasion, and then from 4 to 6 it's giving the logarithmic occasion, and you are requested to write the equivalent exponential form. I saw the first one. If you have e to the power x equals to 9, e to the power x equals to 9, then len 9 at the base of e equals x. Len 9 at the base of e, but we are not writing e because by default len, it is logarithm at the base of e. So len 9 equals to x. Here len m equals to 3, len y equals to 10. Now, problem number 4, len x equals 3.54. This is logarithmic occasion, or logarithmic form. In order to write the exponential form, then it is, don't forget that the base here is e. So e to the power 3.54 equals to x. E to the power 4.5 equals to x, and the same way you can solve for 5 and 6. I said len, it is a natural logarithm, so it is logarithm. So all rules of logarithm will be applied. Rule number 1, if you remember, this is rule number 1. Len xy, len x multiply, this is multiplication. So len xy equals len x plus len y. So now here I have addition, and here I have multiplication. So as you see, multiplication becomes addition. Multiplication inside the len becomes addition outside the len. Rule number 2, what if I have division? Inside len I have division. Now the division, it becomes subtraction. So len x divided by y, or x over y, x by y equals len x minus len y. And finally, the power rule or power property. If you have len x to the power m, then m will become multiple. So it's coming in front of len. So len x to the power m, this is m len x, m len x. And don't forget that len e equals to 1. Why? Because this is len e at the base of e. And don't forget last time for common logarithm, we said log b at the base of b equals 1. So you can say log e at the base of e equals 1. And the same thing, len 1 equals to 0. So multiplication, here multiplication becomes addition, division becomes subtraction, and power rule, power becomes multiple. And then len 1 equals to len e equals to 1, and len 1 equals to 0. Now we want to learn how to write or to how to simplify by using rules of logarithm. I want to write each expression as a single logarithm. For example, number 1, I have 2 len x minus len y. First of all, I have to, I'll just explain how to solve in detail the first one. And the first one, I provide the answer directly. It is len x squared by y, or divided by y. But first of all, I have to find, this is the equation again, 2 len x minus len y minus len y. First of all, this is multiple, or the number here, multiple. It will go back to its origin as power. So this will be len x squared minus len y. Then after that, this is minus. And we'll go to rule number 2. We said the division becomes subtraction. So this will be len x squared divided by y. So I solved number 1, and it's your turn to solve number 2, 3, and 4 using the same approach or the same procedure. Okay, we come to the most important thing in this section, how to solve equations involving natural logarithm and exponential. Well, I tried to write these steps as procedure consists of 4 or 5 steps. First of all, identify whether the equation is in log form or exponential form, then get the log or len portion by itself. Okay, instead of having 3 or 4 terms, should be just one of itself in one sides. Then rewrite into either log or exponential. If it is logarithmic form, then rewrite it in exponential form. If you start with exponential, you have to apply logarithm. Then after that, solve for x and check for your answer. Then identify if the equation is log form or exponential. You can get the log len portion by itself. Then rewrite into log or exponential, then solve. Let's just apply this equation, apply this procedure in solving this equation. Let's suppose that I have e to the power x plus 1 equals to 25. This is exponential. Okay, so in order to solve the exponential, I have to apply len. Okay, so when you apply len, you have to apply len to both sides of the equation. Okay, don't forget to apply len to the left hand side, and don't apply it to right hand side. Okay, then len e to the power x plus 1 equals len 25. Well, don't forget that x plus 1, it is power, so it can be written in front of the len as multiple. So x plus 1 len e equals 3.2. How much is len e? I know that this len e at the positive e, so this is 1. So actually, this is x plus 1 equals 3.22. In order to solve for 1, you can just shift 1 to the right-hand side. It becomes minus. So x equals 3.22 minus 1. So the answer, x equals 2.22. Okay. Now it's your turn to solve those 3 problems. Same way, following the same procedure. E to the power minus 3x equals 24. 5 e to the power 2x plus 1 equals 75, and 2 e to the power minus 2x plus 5 equals 120. Just pay attention for number 2 and number 3. I have 5 multiplied by e, so it's much better, first of all, to simplify or to divide by 5. Then the new equation will be e to the power 2x plus 1 equals 75 divided by 5. It equals to, I think, 15. Okay, and same thing here, it will be e to the power minus 2x plus 5 equals 60 because we are dividing both sides by 2. Now, what if I start the equation by logarithmic equation? So this is len 3x minus 5 equals to 2. This is logarithmic equation. In order to solve the logarithmic equation, I have to rewrite in exponential form. How can I write in exponential form? Don't forget that there is a base equals e here. So e to the power 2 equals 3x minus 5. 3x minus 5 equals e to the power 2. So 3x equals minus 5 equals e squared. By using your calculator, shift len 2, you will have that e squared equals to 7.4. So 3x minus 5 equals 7.4. Now solve for x, shift minus 5 to the right, and then divide by 3. Finally, you will have the value of x equals 4.13. So this is how I calculate or solve equation involving len. Another example, what if I have len 5x minus 2 to the power 3 equals to 9? Len 5x minus 2 to the power 3 equals to 9. First of all, and before I write the exponential form, I'm going to use the power property. As you see, power property, 3 will be multiple, so it will be in front of the len. So 3 len 5x minus 2 equals to 9. Then divide both sides by 3. I'll have len 5x minus 2, 9 by 3, it is 3. Then now I rewrite in exponential form. It will be 5x minus 2 equals to, this is e to the power 3, not 3. This is e to the power 3. Now, if you shift minus 2 and then divide by 5, then x equals e cubed plus 2 divided by 5. So the final answer is x equals 4.42. Now it's your turn to solve problem similar to the previous one. Len 2x plus 7 to the power 4 equals 12, and then minus 3x plus 5 equals to 1, following the same procedure. By this, we come to end. Thank you, and hopefully this presentation or this video explain how to solve equations involving exponential natural logarithm for you. Assalamu alaikum wa rahmatullahi wa barakatuh.